electromagnetic induction. And the equations that we saw are, first one, flux, magnetic flux is given by B dot A. This is the first equation that we learned in this topic, right? Magnetic flux is given by B dot A. What is flux? Flux is the lines of force that are passing through a surface, perpendicular to the surface. You take only the perpendicular components, right? So when you have a surface here, say many lines are passing like this, you take each line and split it into what? Components like this. One normal, another one tangential, normal, tangential likewise. And then what? All the normal components are being added up so as to get what? The flux. So flux is what? The sum of all the field lines perpendicular. This one, all the perpendicular field lines are summed up so as to give you what? The flux. What is the unit of flux? Weber is unit of flux. CGS unit is Maxwell. 1 Weber is how much? 10 power 8 Maxwell. Right. That was our first equation. And the second one was Lenz's law. According to Lenz's law, EMF is given by minus d phi by dt. EMF is minus d phi by dt, where phi is the rate of, phi is its flux. D phi by dt is the rate of change of flux. D phi by dt is the rate of change of flux. And then there was another equation for induced charge. Induced charge is given by dq is equal to I times dt. Why? Because I is equal to dq over dt, right? You learned that in current electricity, I is equal to, current is given by charge per time. Charge flowing per second is known as current. I is equal to dq over dt. So if you cross multiply, you're going to get what? dq is equal to I times dt. And this I could be written as EMF by resistance into dt. And then this is Ohm's law. Current is equal to E by R. That is nothing but Ohm's law. And then you could replace this E with this minus d phi by dt. What is EMF here? It is minus d phi by dt over R into dt. dt and dt are cut. You get what? Minus d phi over R. So this is the equation for induced charge. Now that was the third equation. And then there was one more equation I told you. If the magnetic field line is reversed, or if the coil rotates through 180 degree, just imagine the coil is held perpendicular like this. Coil is held perpendicular. When the coil is held perpendicular, area vector is in this direction, field is also in this direction, theta will be 0. When you turn it through an angle of 180 degree, the new angle is 180 because the area vector is in this direction, field is still in this direction, angle is 180. Look at this. You know, this is how I draw it. I have lines going to the right, and then what? This is the surface that I'm holding perpendicular. And area vector now is what? Theta equal to 0, because the area vector is to the right, field is to the right. That would make theta equal to 0. When you turn it through an angle 180, this surface will come over here. So area vector is to this side. Theta will be what now? 180 degree. So in such cases, that means when the coil is rotated through 180 degree, or there can be another case that I didn't tell you about. You know, this is the figure in the first case configuration, no? The area vector is to the right, theta is 0. Instead of rotating the coil through 180 degree, you can change the flux line through 180 degree. How? This was north pole, this was south pole. You could even change the polarities, right? You could make this one north pole and this one south pole. So field lines would be what? Field lines are always going from north to south. So these lines are in the leftward direction. So there can be two ways in which this question can be asked. Number one, if the coil is rotated through 180 degree, or if the flux is reversed, that is what they say. You know, EMF is given by 2NBA by dt. If you remember, we did this in the last class. We even did one question on this. EMF is given by 2NBA. NBA cos 0 minus NBA cos 180. Cos 180 is minus 1. That would make it 2NBA by dt. So these are the equations we learned in the last class, and we'll be doing questions on this in this session. All right. Flux is given by phi is equal to B dot A. What is flux? The number of lines of force penetrating perpendicular to the surface. So actually the lines are making an angle of theta here, but you are concerned about the normal components only. All the normal components are being added up, right? And that is known by the name flux. It is given by the product of, not product of magnetic field and area vector, right? What is the unit of this? Weber is the SI unit. CGS unit is Maxwell, and 1 Weber is 10 power 8 Maxwell. And then according to Lenz's law or Faraday Lenz's law, EMF generated is given by minus d phi by dt. d phi by dt stands for what? Rate of change of flux. And then induced charge. How do we get induced charge? Charge is given by I into dt, I into dt. This is a frequently asked question. I will be what? EMF divided by resistance into dt. So EMF value is minus d phi by dt by r into dt. dt and dt are cut, you get minus d phi by r. And then we have a special question here. Like I told you, the coil is rotated through 180 degree, or the coil is held stationary, the flux is reversed. Okay, the field lines are reversed. In such case, EMF would be given by what? 2NBA divided by dt. Did you understand? See question number 7. A 10 ohm resistance coil has 1000 turns, and at a time 5.5 into 10 power minus 4 Weber of flux passes through it. If the flux falls to 0.5 into 10 power minus 4 Weber in 0.1 second, find the EMF generated in volts and charge flown through the coil in coulombs. So we've been given everything. It's an easy question, direct one. Since you know the equations, it's easy now. A 10 ohm resistance coil. So resistance is what? Resistance is a 10 ohm resistance, right? The coil has a resistance of 10 ohm. What else? And at a time, the flux is 5.5 into 10 power minus 4. So flux in the first case is given 5.5 into 10 power minus 4 Weber. What is the flux in the final case? They have given the final flux also. Final flux is, if the flux falls to 0.5 into 10 power minus 4. Flux is falling to what? 0.5 into 10 power minus 4 Weber. Right. So you've been given the initial flux and the final flux. And this happens within a time of 0.1 second. So time interval is also given. dt is equal to 0.1 second. So in this chapter, if you write down the data, you'll definitely get the answer to the question. Okay, it's an easy question. Find the EMF generated in volts and charge flowing through the coil in coulombs. What is the equation for EMF? EMF can be written as minus d phi by dt, right? That is minus of, what is d phi? D phi stands for difference in flux. D phi stands for difference in flux. So phi 2 minus phi 1 over dt. What are the values? I can put them over here. Minus phi 2, 0.5 into 10 power minus 4 minus phi 1. Phi 1 is 5.5 into 10 power minus 4 over dt. dt is 0.1 second. What do we get then? This is minus 0.5 into 10 power minus 4 minus 5.5. 0.5 minus 5.5 is 5 into 10 power minus 4. Oh, there is a negative sign. Already there is a negative sign. This is smaller quantity. This is bigger quantity. When you subtract, you are getting a negative quantity, right? Negative multiplied by negative is positive. Divided by 0.1. This is like 10 raised to minus 1. So I can cut them. What do I get? 5 into 10 power minus 3. It is EMF that they're talking about. So it is in volts. EMF is given in volts. Second part of the question is to find charge, dq. It is what? Minus d phi over r. Minus d phi by r. Tell me how you find this? D phi is the numerator here, right? D phi is the numerator here. I can take it straight away from this, right? This is 5 into 10 power minus 4 with a negative sign. No, negative and negative plus. Divided by the resistance is given 10. That would make it what? 5 into 10 goes numerator, 10 power minus 5 coulomb. Charges in coulombs. Did you understand? A 70 turns coil with an average diameter of 0.02 meters is placed perpendicular to a magnetic field of 9000 Tesla. If the magnetic field is changed to 6000 Tesla in 3 seconds, what is the magnitude of induced EMF? It is not magnetic of, it is magnitude of induced EMF. There is a correction in the question. So read it again. A 70 turns coil. So number of turns is given. Number of turns is 70. There are 70 turns for the coil. Then what? With an average diameter of 0.02 meters. Diameter is 0.02. That would make the radius what? Radius 0.01. So that you can find the area. Area is what? Pi r square. Right. So that is pi into r square is what? 0.01 square. That is what? This is 10 power minus 2. 10 power minus 2 square is what? 10 power minus 4 pi meter square. That would be the area. Then what? Magnetic field of 9000 Tesla. The magnetic field is given, it is 9000 Tesla. And what's happening to this magnetic field? This magnetic field is changed to 6000 Tesla. Now this is being changed to 6000 Tesla. 6000 Tesla in how many seconds? dt is given 3 seconds. You've been asked to find what? The induced EMF. So you've been given everything. Number of turns is given to be 70 turns. There are 70 turns on the coil. Then area, how do you find area? Diameter is 0.02. Radius is half of it, which is 0.01. And then area is pi r square, that is pi into 0.01 square. 0.01 is what? In fact, it is 10 power minus 2, the square of which is 10 power minus 4, 10 power minus 4 pi meter square. And they have given the initial magnetic field. The magnetic field is reducing from 9000 to 6000. So 9000 to 6000. And then initial field is 9000, final field is 6000. And then time is given, it is 3 seconds. You've been asked to find the EMF. What is the equation? EMF is given by minus d phi by dt. That is minus of phi 2 minus phi 1 by time dt. That is equal to minus of, what is phi 1? Phi 1. Phi 1 can be written as B1A. Sorry, B2A minus B1A. Why? Because flux is equal to, we learned it in the beginning, flux is equal to B into A. Correct? So we can take what? Flux in the second case as phi 2 as B2 times A and phi 1 as B1 times A. Phi 2 is B2 times A, phi 1 is B1 times A, divided by dt. So let us put the values. What do we get then? Minus of, what is B2? B2 times A is common, so I can take it outside. Okay, A value I can put outside, 10 power minus 4 pi, divided by, time is 3 seconds. What is B2 minus B1? B2 is 9000 minus B1 is 6000. So the difference would be what? Minus of, B2 is 6000. Okay, B2 is 6000, this is 9000. That would make it what? 6000 minus 9000, 3000. Minus 3000, minus or minus, plus 3000 by 3 into 10 power minus 4 pi. So 3 and 3 are cut. 1, 2, 3 zeros are cut with this, 10 power minus 1. So the answer is 10 power minus 1 pi volts. 10 power minus 1 pi volts. Did you understand? Question number 8. A closed coil consists of 500 turns on a rectangular frame of area 4 centimeter square and has a resistance of 50 ohm. It is kept with a plane perpendicular to a uniform magnetic field of 0.2 Weber per meter square or 0.2 Tesla. Calculate the amount of charge flowing through the coil when it is turned over. The coil is turned over, rotated through 180 degree. They have given in bracket. You are turning it over means what? You are rotating the coil through 180 degree, right? Will this answer depend on the speed with which the coil is rotated? That's an important aspect of this question, okay? So a closed coil consists of how many turns? The closed coil has 500 turns. The closed coil has 500 turns. Okay, the closed coil has 500 turns on a rectangular frame of area 4 centimeter square. So area is given 4 centimeter square, 4 into 10 power minus 4 meter square, right? Area is given 4 into 10 power minus 4 and has a resistance of 50 ohm. Resistance is given, resistance is 50 ohm. Okay, it is kept with its plane perpendicular to uniform magnetic field of 0.2 Tesla. So magnetic field is also given 0.2 Tesla. Weber per meter square is same as Tesla. All right. Okay. Calculate the amount of charge flowing through the coil when it is turned over. Underline that part. The coil is turned over means the coil is rotated through 180 degree. You've been asked to find the charge. Okay. dq is equal to how much? That's the question. Will the answer depend? We'll do one by one. Okay. So I'm looking at this question first. dq is equal to what? Minus d phi divided by r. I would say that it is plus 2nba divided by r. Do you want me to show this? Prove this? I can do that if you want. Minus d phi by r. I'm doing it on the right side anyway. Phi 1 is equal to what? nba cos 0. Why? Because they say the coil is held perpendicular. Coil is held perpendicular means what? This is how the coil is held. Look at this, look at this. This is how the coil is held. Area vector is to the right, field is to the right, theta will be 0 in first case. Theta is 0. So NBA cos 0 is what? NBA. And phi 2 is what? Phi 2 is NBA cos 180, because you are turning it over, right? As it is turned over or rotated through 180 degree, you know, this area vector will be to the left side. Angle is 180 degree, right? So if you put it over here, you get cos 180. Cos 180 is minus 1. That would make it minus NBA, right? So I can put it straight away to this equation. Where is it? Okay, minus d phi is what? Minus d phi is what? Or d phi is what? Difference in phi's, right? D phi stands for difference in phi's. So minus NBA minus NBA. That makes it minus 2 NBA. Minus 2 NBA of minus. So minus or minus plus 2 NBA by R. Hope you got this. So this is what? 2 into number of turns is there. It is 500 into magnetic field. Magnetic field is given. It is 0.2. Area is given 4 into 10 power minus 4. 4 into 10 power minus 4 divided by the resistance is given 50. So let us cut 50 and 500. It is 10. Then 2 into 10 into 0.2. That is 2. 2 into 2, 4. 4 into 4, 16. 16 into 10 power minus 4. It is charge. So Coulomb. And remember, as you can see, you don't see time here. So this induced charge doesn't depend upon what? The speed at which the coil is rotated. There is a second part of this question. Will this answer depend on the speed with which the coil is rotated? It doesn't matter. You are looking at initial condition and the final condition. Time is involved now. Time is nowhere involved, right? You see any time here? No, no time. So whatever be the speed in which it is being rotated, you are looking at the initial and final positions, no? So time or speed or time won't influence the final value here. But on the other hand, had this been EMF, had this been EMF, we would have written minus d phi divided by, minus d phi by dt, minus d phi by dt. There is time involved. So if it is EMF, definitely there will be change as the speed of rotation changes. But in this case, when you calculate the charge, there is no change as such. Understood? Because the equation for charge does not include what? Time. You don't see time here, you don't see time here. N, B, A, R, all the terms are independent of time. Nothing happens to N, B, A or R when time changes. Did you understand? Question number 9. A conducting rod held horizontally along east-west direction is dropped from rest from a certain height near Earth's surface. A conducting rod held horizontally along east-west direction is dropped from rest from a certain height near Earth's surface. Why should there be an induced EMF across the ends of the rod? So, hope you remember this. Okay, before coming to the question, I'll give you theory part, right? You can write heading Motional EMF, right? I'll give you all the necessary equations here. Motional EMF. What is meant by motional EMF? You know, it is clear from even from the name, no? Motional EMF is EMF due to motion. See this? I have a magnetic field here. In which a metallic conductor is placed. This is a metallic conductor of length L. Now, if I pull the conductor inside the magnetic field, electrons will be clustered at one end, which will become negative, and the other end becomes positive. That means this will become a cell. The conductor acts like a cell. A voltage is developed along the length of the conductor, across the conductor. And this EMF is known as motional EMF. Repeating one more time, we have a metallic conductor. The metallic conductor is being pulled inside a magnetic field. Just take a rod, metallic rod. Just take a metallic rod, you just pull it across like this. Okay? Now what happens is, electrons are experiencing a Lorentz force. The Lorentz force pulls the electrons to one side. That end becomes negative. The other end, which has lost electrons, becomes positive. Right? So you got one positive terminal, another negative terminal. That makes it a cell. Right? And the EMF is given by, motional EMF is given by BLV. B is the magnetic field. L is the length of the conductor. V is the velocity with which the conductor is moving. That is equation number 1. Equation number 2, this is the equation for motional EMF due to motion of the conductor. And then the power developed on the conductor, electrical power, P electrical, power developed. Because why is the power developed? When the conductor is moved, there is an EMF generated. The EMF causes a current, and there can be a power developed. Okay, and the electrical power is given by what? E square divided by R. You learned this in class 10. Power, Joule's law of heating. E square over R. What is E square over R? It is BLV, the whole square over R, which makes it what? B square, L square, V square by R. So that is B square, L square, V square by R. This is electrical power, right? And then there can be another question. What is the mechanical power required? Because as you're trying to pull it, somebody is holding it back. Who is holding it back? When you try to pull it out, as per Lenz's law, whatever is happening should be opposed, right? So when you try to pull it out, the EMF generated should oppose the cause. Here the cause is the rod is going out. Rod will be pulled back, correct? So you have to overcome that attractive force. Understood? Right. So anyway, in that case, you need to apply mechanical power so as to take it out, because somebody is pulling it back. Now, how much of mechanical power is to be given? Same as the electrical power, right? Because that is law of conservation of energy. Lenz's law is what? Lenz's law is, after all, it is law of conservation of energy. That is what we learned in the last session. Mechanical power required to pull the conductor out of the magnetic field is given by P mechanical is equal to P electrical. What is P electrical? We have calculated E square by R, B square, L square, V square by R. Understood? And the last one, force. What is the equation for force? They might ask you to find the force. Force is given by power by velocity. If you don't remember, I can do this. Right. Power is given by what? Power is given by energy by time. Or take it this way. Power is given by work by time. That is force into displacement by time. If you remember, power is given by work by time. Work is force into displacement by time. Displacement by time is velocity. So power is equal to force into velocity. Force will be what then? Power by velocity. This is something you learned in first year classes. I'm taking that equation straight away. I need to find the force required. Force required for what? For pulling the conductor out of the field. Force required for pulling the conductor out of the field is power by velocity. So B square, L square, V square by R, which is the power, divided by velocity. V and V are cut. What do we get then? B square, L square, V divided by R. These equations are very, very important equations. Did you understand? So, what is motional EMF? You have a conductor, you have a metallic wire, and you are pulling the conductor in a magnetic field. You're just moving the conductor in a magnetic field. What happens? When you move it, all the electrons inside will experience a Lorentz force. Due to the Lorentz force, the electrons will be moving downwards. Those electrons will come over here, right? Negative. While the other end, which has lost electrons, is positively charged. And then what? This looks like a cell now with a positive terminal and negative terminal. If you connect a bulb here, the bulb will glow because there exists an EMF now, which can create a current. Understood? And then EMF. This EMF is given by BLV. B is magnetic field strength. L is the length of the conductor. V is the velocity. All right. And then what is the electrical power generated on the conductor? Because when you pull it, there is electricity being generated, which can cause a power. The electrical power is given by E square by R. This is nothing but Joule's law of heating, okay? E square by R, which is BLV, the whole square divided by R. Why? Because E is BLV. This is Joule's law, V square by R. BLV, the whole square over R, which makes it what? B square, L square, V square over R. And then what? As I'm trying to pull it, there is a backward force on it, because Lenz's law says that whatever is happening will be opposed. So when I try to pull it out, somebody is pulling it back. Lenz's law is pulling it back, right? Lenz's force is pulling it back. So what is the mechanical power required? So I definitely need a force or a power to pull the conductor out of the magnetic field. So mechanical power required is same as electrical power. How do you justify this? This is law of conservation of energy. The mechanical power developed on the conductor, required to pull the conductor is same as the electrical power generated on the conductor. So whatever power they ask in this topic, you'll have to use this equation, V square L square V square by R. And if you're asked to find the force, force is power by velocity. How do we get this equation? I've shown it here. Power is work by time, force into displacement by time. Displacement by time is velocity. Power is force into velocity. So force will be what? Power by velocity. B square L square V square by R over B, V. V and V are getting cancelled. You get what? B square L square V by R. Right. Okay, so we have seen motional EMF. Now we're going to see the motional EMF generated when a conductor is rotated. It's a frequently asked question, solved example question on textbook. Okay, we have a magnetic field here. We have a magnetic field here. Right, this is a magnetic field that goes into the board. All right, it is going into the board here. And then I have kept a conductor here which can rotate like this. This is the conductor which can rotate. See this? Oh, that looks pretty good, right? So the conductor can be rotated. And then what? And then what happens is when the conductor rotates, an EMF develops between the ends of the conductor, between this end and this end. So that will act like a, in the previous case, I was just pulling the conductor, but this time around, the conductor is going to be rotated. Okay. So what are we doing here? You're just holding the conductor by one end and then moving the other end around like this. Okay. This conductor is being rotated. You're going to find out the motional EMF generated. How do we find this? Now, before going to this, you need to know this equation, V is equal to R omega from first year classes. This is an important equation that connects linear motion and rotation motion. Linear velocity, that means velocity in linear motion is equal to radius into angular velocity. For example, when the spin rotates, when the spin rotates, whiteboard is written on it. Whiteboard is written on it. Okay. All the letters will have same angular velocity, but all the letters will have different linear velocities because linear velocity is radius times angular velocity. Understood? All the letters are moving through same angle because it's a rigid body. As long as it remains a rigid body, all the letters will be covering same angle, right? So that means angular velocity will be same for all points. This point, this point, this point, this point, this point, every point has same angular velocity. But linear velocity is different. The fastest point is farthest point, and the slowest point is closest point. Understood? As you go away from axis of rotation, the speed will increase. Okay. Anyway, I have a conductor here. Look at this. What I do is, I'll just take a small element here, element at a distance of x and with a width of dx. So what have I taken? I've taken a small element whose width is dx and it is at a distance of x from the center. Okay. And I'm going to find out the motional EMF due to this element. What is the motional EMF due to the small element? Motional EMF can be written as B into dx into V, because motional EMF was written as what? Motional EMF was written as BLV earlier, right? BLV. So for this small element, look at this, the shaded one. Look at the shaded one. For this small element, the shaded element, how do you calculate the motional EMF? BLV. B is B, L is length of the conductor, which is dx, into V. V is velocity, right? So I can just simplify this. B into what is V? I can put the replacement R omega, but R is x here, no? The element is at a distance of x. So B into x omega into dx. This is small EMF. So if I know the small EMF, how do we find the total EMF? The technique is called integration. So if you want to find the total EMF now, you should integrate this B omega x dx from where to where? 0 to L. Because the element can be located here at 0. The element can be located as far away as this point. Understood? The element can be located here, 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 everywhere along the length till the end of the conductor. So integration should be done from 0 to L. 0 to L. Tell me what you can get. This is B is taken outside, omega is taken outside. What is the integration of x dx? X raised to 1's integration is x square by 2 from 0 to L. Okay. And then what? B omega by 2 is taken outside. You give the upper limit first, L square minus, then lower limit 0 square. And that makes it what? B omega L square by 2. B omega L square by 2. This is the equation for motional EMF due to a rotating conductor. And again, one more important point is there. I'll give you an example for this. Look at this. This is a cycle wheel. Cycle wheel has a lot of spokes on it. We have done this during our regular discussion sessions. Cycle wheel has a lot of spokes on it. And each spoke is like a conductor, no? You know, this spokes, one end is at the center, the other end is on the rim. Even for this spoke, one end is at center, the other end is on the rim. For every spoke, one end is at the center, other end is on rim. One end is at the center, other end is on rim. So every spoke is connected between what and what? The center and the rim, center and the rim, center and the rim. So they are like what? Cells in parallel. In the case of cells in parallel, you know, you try this at home if you want. You take a number of cells and connect all the positives together, negatives together, right? Then what? You'll have only one cell. That is the case with parallel combination. Whatever be the number of cells, whatever be the number of spokes, you will have only one spoke. You'll have only one cell. So they might give you like 100 spokes, 1000 spokes, or 10,000 spokes. Whatever be the number of spokes, the equation is B omega L square by 2. This happens for a cycle wheel or okay, that is point number one. Point number two, what if I have infinite spokes then? Infinite number of spokes, infinite number of spokes. Not 1, not 2, not 10, not 100, not 10,000, not 100,000, not million. I got infinite number of spokes. Even then it is B omega L square by 2. So infinite spokes means what? If the spokes, number of spokes is infinity, they are so close that it will look like a disk now. Correct? You know, so that means for even for a disk, compact disk, no, CD, compact disk, metallic disk, if it is rotated near a magnet, the magnetic EMF between center and the rim is B omega L square by 2. That would still be B omega L square by 2 because disk is, this is called Faraday's disk generator or homopolar generator. Homopolar generator. Faraday disk generator or homopolar generator. Because the disk is what? The disk is an extension of a rod. You know, I got one rod here, second, third, fourth, fifth, like this. I got infinite number of spokes. If I got infinite number of spokes, they'll join together. They'll be together on the circle so as to make it look like what? Like a disk. So even for a disk, the EMF is B omega L square by 2. Did you understand? So this is a disk. This is a rod that is being rotated. You hold one end of the rod and the other end is being rotated like this. Like the leaf of a ceiling fan, right? Or leaf of a helicopter fan, or the leaf of a tail fan of a helicopter, right? Or the spokes of a cycle wheel. These are examples, no? Okay. And then I told you we have a conductor here. The conductor is rotated in a magnetic field. There is a voltage or EMF developed between the ends of the conductor, this end and this end. And this EMF is known as motional EMF. How do you find it? How do you find the expression? You take a small element of length dx at a distance x from the edge, the fixed edge, the pivoted edge, right? And then you let it rotate. You're going to find the EMF due to this small segment. What is EMF? EMF is given by BLV. So B into length is dx into velocity is v. Okay. And then d is equal to b into what is velocity? Velocity is r omega. So here r is x because you consider the element at a distance of x from the fixed end, right? So x omega into dx. And I'm rearranging it b omega into x raised to 1 into dx. And where am I integrating it from? I'm integrating it from 0 because element can be located here at the fixed end, right? And till this end. So 0 to L. Integration should be done from 0 to L. B omega x raised to 1 dx. So b omega x raised to 1 dx integration is x square by 2, 0 to L. So b omega by 2 into L square minus 0 square. So b omega L square by 2. This is the equation for EMF generated due to a rotating conductor. Like I said, if you got n conductors rotating together, we won't be looking at the number of conductors because these are like cells connected in parallel. In the case of cells in parallel, we learned in current electricity that the number of cells is not to be taken. So obviously, we don't take this. We don't count the number of rotating conductors here. So eventually, it is what? B omega L square by 2 for anything, even for a disk, Faraday disk generator. Okay. So we'll go to question number 1. No, question number 9. Take the question paper. Question number 9. We'll do a few questions on this and then I'll give you some extra questions. Question number 9. These are all previous board questions. Question number 9. A conducting rod held horizontally along east-west direction. This is east-west direction for me, right? And it is falling from rest at a certain height, okay, near Earth's surface. Why should there be an induced EMF across the ends of the rod? Why should there be an EMF? Because this conductor is what? Conductor is cutting a magnetic field. Whose magnetic field? Earth's magnetic field. Earth has magnetism, right? We learned that in geomagnetism, in magnetism and matter. Understood? This question was asked in another way. In one of the examinations, you are landing on a new planet. How do you check the presence of a magnetic field there? How do you confirm if there is a magnetic field? You take a wire, you connect a bulb, and then you move it. If the bulb glows, that means there is a magnetic field on the planet. Just imagine you are landing on a random planet, okay, a planet X. Then what? You are asked to confirm whether there is a magnetic field on the surface of the planet. How do we do this? You take a rod, metallic rod, and connect a bulb at the ends without any cell or anything, right? And then what? You just move it across like this. If the bulb glows, that means there is a current. Which means what? Which means what? Which means the rod has positive polarity and negative polarity, right? That means motional EMF has been generated. Motional EMF is generated only if a magnetic field is present. So this question is similar to that one. They say a conductor is held in the east-west direction. It is falling like this. Now when it falls, EMF is generated because as it is falling down, it is held in the east-west direction and it is falling down, right? It is cutting Earth's magnetic field. So what happens? Electrons inside will experience Lorentz force, due to which they will move to one side. One end is negative, the other end is positive. Now, there is second part. Draw a plot showing variation of instantaneous EMF as a function of time from the instant it begins to fall. This is a very important question, okay? Draw a plot. So, draw a plot of what? Draw a plot of variation, instantaneous variation of EMF. Look at this. What is the equation for EMF? BLV. I need to draw the graph, right, with the time. They say I need to draw the graph as a function of, tell me what? Draw a plot showing instantaneous variation of EMF as a function of time. So I should introduce time here. How can I introduce time? V is equal to U plus AT, right? Initial velocity plus acceleration into time. Equation of motion. Initial velocity is 0 because you are dropping the rod, right? And then V is equal to what? GT, because acceleration is equal to acceleration due to gravity. So let's put it over here. B, L, G, T. This is EMF. As you can see, B is a constant, L is a constant, G is a constant. So E will be directly proportional to T. So if you draw the graph of EMF against time, the graph would look like this. But in some of the guides and textbooks, you might see the graph in this quadrant. There is nothing wrong because the EMF can also be written as minus BLV in some cases. Actually, in textbook, they have taken it as minus B. But it doesn't matter because eventually you're taking the magnitude. So if you see something like this, don't be confused. You could draw this graph or this graph. Either way, it is correct. I'm repeating one more time. What is the question? Question number 9. A conducting rod held horizontally along east-west direction is falling down. Why is an EMF generated between the ends? Why is the EMF generated? You can write it down. Because when the conductor falls, it is cutting what? It is intercepting Earth's magnetic field lines. Earth's magnetic field lines are everywhere around, right? Yes. Right in front of my eyes, I can see magnetic field lines, right? Earth has magnetic field lines, no? We have learned this in magnetism and matter. There is a horizontal component, there is a vertical component. So when the conductor falls, it is cutting which component? Horizontal component. Understood? When a plane flies, the wings are cutting which component? Vertical component. Okay. When a fan rotates, ceiling fan rotates, it is cutting what? Vertical component. This is the leaf of a fan. So when it rotates, it is cutting vertical component. When the fan of a helicopter rotates, that is also cutting vertical component. Vertical component, do you remember? Vertical component was B sine delta and horizontal component was B cos delta, if you remember from magnetism and matter. Right. We'll see that in next session. BV is equal to B sine delta and BH is equal to B cos delta, where delta is called dip or inclination, because there have been situations in which they would give you the delta value and they'll ask you to find the EMF. So don't put B as such. You'll have to find B sine delta or B cos delta depending upon the situation. For example, when a plane flies, when an aeroplane flies, it is cutting what? Vertical component. This is the wing of an aeroplane, wings of an aeroplane, no? And that is cutting what? These wings are cutting what? Vertical component. Understood? Or even the axle of a train. This is the axle of a train. Axle means what? This is one rail, another rail. This is one wheel, another wheel, and there is an axle. Axle means the rod that connects the wheels together, right? And this rod is cutting vertical component. Anyway, the question here is what? In this question, they are asking you why an EMF is generated. Why is an EMF generated? Because when the conductor falls, Earth's magnetic field lines are intercepted. Earth's magnetic field lines are cut. Okay, whenever Earth's magnetic field lines are intercepted, the electrons will move over to one end, leaving the other end positive. This end is negative. So an EMF is generated. Second part of the question is to find an EMF, equation for EMF in terms of time, as a function of time. You have to plot the graph. So EMF is given by BLV. What is V? You should incorporate time somehow. Velocity is U plus AT. V is equal to U plus AT as it is falling under gravity. Then V is equal to initial velocity is 0 because you are dropping the body. 0 plus GT. Acceleration is GT. So E is equal to BLGT. All right. And then B is a constant, L is a constant, G is a constant. So you can put E is proportional to time. Since it is direct proportionality, the graph must be a straight line. So if you draw the graph of E against time, the graph is a straight line. And like I said, in some of the textbooks, they have given this graph. Don't be worried about it, because in some cases, it will be minus BLV, depending upon the direction which the conductor is moving. Okay, so it can be what? Minus T. So that is why the graph is in fourth quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. Anyway, the graph is a straight line. Did you understand? Question number 10. A jet plane is traveling. Towards west at a speed of 1,800 km per hour. A jet plane is traveling towards west at a speed of 1,800. So velocity is given 1,800 into 5 by 18. 18 and 18 are cut. You're getting what? 200 into 5. That is 1,000 meter per second. So a jet plane is traveling at a speed of 1,000 meter per second. What is the voltage difference developed between the ends of the wings having a span of 25 meters? Span is 25 meters. Wingspan means, see, this is how the plane looks like, right? Wing of an aeroplane, right? Again, wings of an aeroplane, they would look like this, no? The wingspan, the distance between them, that would be taken as a conductor, no? So these are the wings. Wing number 1. So I got the plane has got 2 wings like this, and wingspan is nothing but the length of the wings together, right? Length of the conductor. So I got the length of the conductor as 25 meters. Wingspan is given 25 meters. What else is given in the question? Having a span of 25 meters, if the Earth's magnetic field at the places 5 into 10 power minus 4. Magnetic field is given 5 into 10 power minus 4 Tesla. And then dip angle is given. Dip angle delta is 30 degree. Okay. So again, it's a multi-concept question. What is the case here? An aeroplane is flying. When the aeroplane flies, it is cutting what? This is the wing. Okay. The wings are cutting what? The wings are cutting vertical component of Earth's magnetic field, not horizontal. Okay. So when the plane flies, the wings are intercepting vertical component of Earth's magnetic field lines. Even the axle of a train is also cutting vertical component. Understood? Okay. Anyway, here it is vertical component. So what is the equation? EMF is given by, they are asking you to find the EMF developed between the wings of the conductor, ends of the wings of the conductor. Okay. BLV. But here, be very careful. BLV, out of BLV, this is BV, vertical component, right? Because as the conductor moves, it is intercepting vertical component here. Look at this. It is intercepting vertical component. Okay. So BV into LV. I have to find BV here. BV is what? B sine delta. B sine delta. What is B? 5 into 10 power minus 4 into sine delta. Sine 30. Sine 30 is 1 by 2. Sine 30 is 1 by 2. 5 into 1 by 2. 2.5 into 10 power minus 4. Okay, so 2.5 into 10 power minus 4. Length of the conductor is wingspan, that is 25. And velocity is what? Velocity is 1000. Tell me what you're going to get. This is like, you know, 3 zeros are cut with this. You got 10 power minus 1. So this is 2.5. 10 power minus 1 into 25 is 2.5. 2.5 into 2.5 is 6.25 volts. Did you understand this? So I made a mistake. This is 18 and 18 are getting cut. It is 500. 5 into 100 is 500. I wrote it as 1000 earlier. Okay. So I had to make the change here. It is 500. So that will change our final value. Minus 4. Okay. So it's 10 power minus 4. Let us do the calculation one more time. 110 is taken with this 25. So 25 into 25, 625. This is made 25 by taking 1 0 with this 25. 25 into 25, 625 into 50 is 3125. Right, into 10 power minus 4. So the answer is 0.3125 volts. 625, 6250 by 2, 3125. Did you understand this? Question number 11. We are on question number 11 now. Figure shows a rectangular loop of conducting PQRS in which arm PQ is free to move. A uniform magnetic field acts in a direction perpendicular to the plane of the loop. Arm PQ is moved with a velocity V towards arm RS. So I'll draw the figure, okay? So I have PQRS, okay? So this is a rectangular frame on which you're keeping a movable frame, PQRS. Look at this. It looks like a rectangle now, PQRS. And it is moving where? It is inside a magnetic field. As you can see, magnetic field is into the board, right? So we have a magnetic field, all right. Magnetic field that is into the board. Okay, figure shows a rectangular loop conducting PQRS. Conducting loop. PQRS is a conducting loop. It's a rectangular frame on which the conductor can move. Okay, a uniform magnetic field acts in a direction perpendicular to the plane of the loop. So there is magnetic field lines. There are magnetic field lines, right? And arm PQ is moved with a velocity V towards arm RS. They have given in the figure. Assuming that the arm QR, PS, and RS have negligible resistances. All these have negligible resistances. And then PQ has a resistance of R. PQ has a resistance of R. Okay, this has negligible resistance. This one, even this one has negligible resistance. Only the rod has a resistance. And then what? Obtain the expression for current in the loop, the force, and the power required. It's a 3-mark question again. Obtain the expression for current in the loop. How do we get this? First of all, you have to do the derivation for EMF. I'll do the derivations in a separate session, okay? So I'm not trying the derivation now. It's easy actually. We have done this, but it's very, very important. The EMF should be found out first. EMF is BLV. The motional EMF is very easy to do. If you insist, I can do it now. Anyway, I'll do it in the end. Okay, E is equal to BLV. Then you can take EMF. EMF is what? Ohm's law. Ohm's law says that EMF is, current. Current is voltage by resistance. So that makes it what? BLV divided by R. So that answers my first part of my question. Right. Second part is what? They're asking you to find the force and then the power. So before finding force, you should find power. So let us do third part first. What is the equation for power? Never learn this by heart. E square by R. E square by R. What is E? You have written E here, BLV. So BLV the whole square over R. It is B square, L square, V square by R. So second question now. They are given in the wrong order. You have to find power first. Then only you can find force. So what is force then? Force is power by velocity. Power is what? B square, L square, V square by R by V. V and V are cut. So you get B square, L square, V by R. Did you understand? So when such a question is asked, you have to derive the equation for EMF. EMF is BLV. Actually, it comes from the EMF equation minus d phi by dt. I'll show that in the end. EMF is BLV. So obviously current is given by Ohm's law. Current Ohm's law says that current is voltage by resistance. That is BLV divided by R. EMF is BLV by R. And then power, if you want, power is given by E square over R. That is BLV the whole square by R. B square, L square, V square by R. And then the last question is on force. I have changed the order. I have to do part 3 first, then I can go to part 2. Tell me, force is power by velocity. Power is B square L square V square by R by velocity is V. V's are getting cancelled, you're getting B square L square V by R. Did you understand? Read question number 12. A rectangular conductor LMNO is placed in a uniform magnetic field of 0.5 Tesla. A rectangular conductor of LMNO. A rectangular conductor LMNO. Look at this. LMNO. A rectangular conductor LMNO is placed in a magnetic field, as you can see. Magnetic field. It is placed in a magnetic field. Rectangular conductor LMNO is placed in a magnetic field. Then what else? Magnetic field of strength 0.5 Tesla. So magnetic field is given 0.5 Tesla. Then what? The field is directed perpendicular and into the plane of the conductor. Okay. When the arm Mn of length 20 centimeter, this is having a length of 20 centimeter, which means it is 0.2 meters, is moved towards left with a velocity of what? 10 meter per second. 10 meter per second. Calculate the EMF induced in the arm. Calculate the EMF. So you've been asked to find the EMF. Direct question. Direct question. Given the resistance of the arm to be 5 ohm, resistance is 5 ohm. You've been asked to what? Find the value of current in the arm. So direct question again. What is the equation for EMF? You are moving the conductor and the EMF is given by BLV. Right. That is what? B is 0.5 Tesla. Length is 0.2. Velocity is 10. Multiply 0.2 into 10. That is 2. 2 into 0.5. 1 volt. Simple question, but direct question, but it's been asked many times, right? This is the EMF. So current is given by EMF by resistance. So 1, EMF is 1, resistance is 5, 1 by 5 is 0.2 amperes. 0.2 amperes. Did you understand? Moving on to question number 15. A metallic rod of length L is rotated at an angular speed omega, normal to a uniform magnetic field R. Magnetic field B. Derive an expression for the EMF induced in the rod, current induced in the rod, heat dissipation if the resistance of the rod is R. Read it again. We have a conductor here. We have a metallic rod of length L rotated at an angular speed omega. L rotated at an angular speed omega. So we have a conducting rod L of length L rotated at an angular speed omega. In a magnetic field, the magnetic field is into the board. What is the question? Derive an expression for EMF induced in the rod. So you got to find an equation for EMF induced in the rod, which we have done already. Rotating conductor. You take a small element of length dx at a distance ex. Then the EMF due to the small element is d is equal to b into dx into v. Then b into dx into v can be written as x omega, and you will integrate from 0 to L. In the end, you will get the EMF as b omega L square by 2. It's a 5-mark question. First part is EMF induced in the rod, for which the answer is E is equal to b omega L square by 2. Yeah, sure, Masna. Right. E is equal to b omega L square by 2. Right. And then what? Current induced in the rod. You got to find the current induced in the rod. Current is given by E by R, Ohm's law. That is what? B omega L square by 2 by R. So that makes it B omega L square by 2R. So that is second part. The third part is to find out the power dissipation, the heat dissipation. What is the equation for heat dissipation? If you remember, heat dissipation is given by E square by R into T. That is what Joule's law of heating says. V square by R into T. So that is what? E is what? BLV, the whole square by R into T. So the final answer is, oh, I made a mistake. It is not BLV. That is for us conductor moving in a straight line. But this conductor is rotating. So the EMF is what? B omega L square by 2. So when you take the square of it, B square omega square L raised to 4 into T divided by 2 square is 4 times R. That will be the final answer. So what is the question? The question is to find the EMF due to a rotating conductor, which we have already derived. You have a conductor whose one end is pivoted and the other end is being rotated. You got to find the EMF using this equation. You take a small element dx, small element of width dx at a distance x from the fixed end. And then what? EMF due to the small element is BLV. L is dx here, small element. Okay. And then V is written as what? V is equal to R omega. Here it is X omega. And then what? You integrate this from where to where? From this point to this point, 0 to L. So integration should be done from 0 to L. You are getting the final answer as B omega L square by 2. This is the equation for motional EMF due to a rotating conductor. And then the second part of the question is to find the current. It is easy to find as Ohm's law can be directly applied. I is equal to E by R. E is B omega L square by 2 by R, that is B omega L square by 2R. Okay, and then the third one, the heat generated. They say power dissipation, heat dissipation if there is a resistance of R. What is heat dissipation? It is given by Joule's law of heating, V square by R into T. So E is what? In this particular question, EMF is B omega L square by 2. I put it here, B omega L square by 2 the whole square into R by R into T. So B square omega square L square square is L raised to 4 divided by 2. 2 square is 4. 4 into R into T. Did you understand this? Question. Question number 16. A wheel with 8 metallic spokes. I told you in the case of metallic spokes, number of spokes is insignificant, irrelevant. That is not to be counted. Okay? That is not to be taken into consideration. A wheel with 8 metallic spokes. I don't mind whatever be the number is, whatever be the number. Each 50 centimeter long. So length is given. Length is 50 centimeters. 50 centimeters is actually half meter. Right. So length of the rod is half meter, is rotated with a speed of 120 revolutions per minute. So remember, it is given in RPM. So you can find RPS. How do you find RPS? Revolutions per minute, RPM. RPM stands for what? Rotations per minute or revolutions per minute. If you see this in a question, you should convert this to RPS, revolutions per second or rotations per second. How do we do this? 1 minute is 60 seconds. So RPM is to be converted to RPS. You have to divide by 60. 0, 0 are cancelled. You get 12 by 6, which is 2. So 2 RPS. Okay, let's go on doing. Then what? Horizontal component of normal in a plane, normal to horizontal component of Earth's magnetic field. Earth's magnetic field at the place is 0.4 Gauss. So magnetic field is given 0.4 into 10 power minus 4 Tesla. Why 10 power minus 4? Why this 10 power minus 4? Because it is given in Gauss, which is CGS unit for magnetic field, but you need to convert that to SI. Tesla, no? 10 power minus 4. Then what else? And the angle of dip is 60 degree. Angle of dip is 60 degree. Okay, 60 degree. And then what? Calculate the EMF induced between the axle and the rim of the wheel. Axle and the rim of the wheel. How will the value of EMF be affected? If the number of spokes were increased. Right. Second part you already know. Anyway, here spokes are rotated. Spokes are rotated. So what is the equation for EMF? A conductor is being rotated. So B omega L square by 2 should be the EMF. Okay, EMF is given by B omega L square by 2. So B is there, right? But remember, it is rotated in which plane? It is rotated normal to horizontal component. So normal to horizontal component, normal to horizontal component. So it is rotated in this plane. It is cutting which component? Horizontal component. So this has to be what? BH. I need to rewrite it as BH. Why? Because they specifically say it is rotating in which plane? It is rotating in a plane normal to horizontal component. This is normal horizontal component, right? When I say horizontal component, take a horizontal line right in front of your eyes. Okay. Vertical component is this, horizontal component is this. So it is rotating perpendicular to this, which means this horizontal component is being intercepted. Okay, so BH is equal to BH should be used here, no? So I'm finding BH here. What was the equation for BH? If you remember, B cos delta. So 0.4 into 10 power minus 4 into cos delta cos 60. Cos 60 is what? Cos 60 is what? Cos 60 is 1 by 2. Cos 60 is 1 by 2. 2 and this are cut. This is 0.2. So let us put them over here. Put the values here. 0.2 into 10 power minus 4 into omega value I need to find out 2 pi times f. Omega is 2 pi into f. You've been learning since class 8. 2 pi into f is 2 here. So that makes it 4 pi radians per second. That is omega value. I can put it here. 4 pi into L square. L square. L is 1 by 2. 1 by 2 into 1 by 2 by 2. Simplify this. 2 into 2 is 4, gets gone. 0.2 and 2 is 0.1. So you get what? 10 power minus 4, 10 power minus 1, 10 power minus 5. So pi is already there into 10 power minus 5 volts. Second part of the question is what? They are asking whether the EMF will be affected if number of spokes were increased. Number of spokes is insignificant. I told you, no? Be it 10 spokes, 100 spokes, 1000 spokes, 10,000 spokes, 8 spokes, 10 spokes, whatever you have, the EMF is always given by B omega L square by 2. Number of spokes is irrelevant. Number of spokes is insignificant. Did you understand? Okay, question number 17. A coil is mechanically rotated with the constant angular speed omega in a uniform magnetic field which is perpendicular to the axis of rotation of the coil. Read it again. A coil is mechanically rotated. That means water is falling on it and it is being rotated. Okay. A coil is mechanically rotated with constant angular speed omega. Constant angular speed omega in a uniform magnetic field which is perpendicular to the axis of rotation of the coil. The plane of the coil is initially held perpendicular to the field. The plane of the coil is initially held perpendicular to the plane of the coil. Plot a graph showing variation of magnetic flux and induced EMF in the coil as a function of time. Mark it as important point. Again, important question. What is the case? A coil is mechanically rotated. This is a coil that is rotated in a magnetic field. It is being rotated like this. The coil is being rotated, okay, in a magnetic field about this axis probably, okay. It has a turbine on it. Water is falling on it. Turbine rotates. The coil is rotating. Okay. Anyway, what is the question? The plane of the coil is initially held perpendicular to the field. The plane of the coil is initially held perpendicular to the field. That is true. This is north pole. This is south pole. Okay. The field lines are going from north to south and the coil is held perpendicular. So that theta is 0. Right. Area vector is in this direction. Field is in this direction. Theta is 0. Okay. What is the question? Plot a graph showing variation of flux and EMF. What is the equation for flux? Flux is given by BA cos theta. Flux is given by B dot A, or it is BA cos theta, or it is BA cos omega t, because theta is omega t, right? Forget about it, BA cos theta. What is EMF? EMF is minus d phi by dt. What is it? Minus B into A into, what is the derivative of cos theta? Minus sine theta, minus sine theta. So minus or minus plus BA sine theta. Look at this. Flux is BA cos theta. EMF is BA sine theta. If there are n turns, I must attach an n to it. So here also I have an n. So here also we'll have an n. Okay, plus n. Okay. So see the functions here. For flux, the function is cos function, and for EMF, the function is sine function. Now you can plot the graph. How do we plot a cos function and a sine function? This is flux graph, and here I will take time. This is EMF graph. So I'll have to draw the periods here, time periods here. Look at this. Time is taken on x-axis, and the sine first function should be cos function, right? Second one should be sine function. Sine function is drawn like this. This is how you draw the sine function, okay? And cos function is what? Cos function is to be drawn like this with a pi by 2 phase difference. This is how flux is drawn, and this is how EMF is drawn. I'm repeating one more time. We have a coil here. The coil is mechanically rotated. That means you are rotating with some force due to wind or water or something. Okay, if it's hydroelectric power station, it is water that rotates the turbine here. Anyway, the coil is rotating. When you start off, the coil is perpendicular to the field, which means what? Field is to the right, area vector is to the right, so theta would be 0, right? So flux I can write what? B dot A, or it is BA cos theta. N turns are there means what? Flux is given by what? Flux equation we wrote it in the beginning. Flux is written as B dot A. B dot A is BA cos theta. If there are N turns, it is NBA cos theta. Okay, and then EMF is minus d phi by dt. This is what Lenz's law says. And minus of N is constant, B is constant, A is constant. What is the derivative of cos theta? Minus sine theta, but you have to use function of a function rule. This is not perfectly all right, but anyway, you just have to know the functions here, trigonometric functions here, based on which the graph is to be plotted. This is a cos function, obviously. And for cos, the differentiation is minus sine. Remember, we are differentiating with respect to time. So there should be function of a function rule. But forget about it. For our question, we won't need it. First one is cos function. Second one is sine function. Right. First one is cos function. Second one is sine function. Tell me what? Cos function is drawn how? Cos function, you know, you have to start from maximum. Then 0. Then maximum. 0, maximum. And sine function is pi by 2 different. Pi by 2 apart. Right. Look at this. When cos function is maximum, sine function is minimum. Cos function is minimum, sine function is maximum. Cos function is maximum, sine function is minimum. Cos function is minimum, sine function. There is a pi by 2 phase difference between sine and cos. So if you have to draw sine this way, you have to start from the origin. Okay. And that is how sine function is drawn. And cos function is drawn with the maximum at 0. That makes sense because you put theta equal to 0. Cos 0 is 1. NBA, that is maximum. That means at 0, you have maximum. Understood? And here, if you put theta equal to 0, sine 0 is 0. This will become 0. EMF is 0. That is why we are starting it from 0, 0. Did you understand? Question number 18. Two identical loops, one of copper and the other of aluminium, are rotated with same angular speed in the same magnetic field. So you got two loops here. One loop this way, another one this way, right? Like this. Okay, there are two loops. One is made of copper and the other is made of aluminium. And these are rotated where? In this with the same angular speed. So this is rotated with omega. This is also rotated with omega. So these are rotated with angular speed omega in the same magnetic field. Magnetic field is also same. Compare the induced EMF and current produced in the two coils. Compare the induced EMF and current produced in the two coils. So it is being rotated. You got to find the EMF first and then the current produced in the two coils. Okay, so what is the equation for EMF? Just give me 1 second. Two identical loops, one of copper and the other of aluminium, are rotated with same angular speed in same magnetic field. So same omega, same magnetic field. Then compare the induced EMF and current produced in the two coils. Justify your answer. Induced EMF. What is the equation for induced EMF? Minus d phi by dt. That is minus d by dt of what is phi? NBA cos theta. Right? Because phi is equal to B dot A. Right? I'm repeating one more time. You've been asked to compare the EMFs first, right? The coil is rotated here, not moved, it is rotated. So E is equal to minus d phi by dt. That is minus d by dt of NBA cos theta. Because this is B dot A. But there are N turns, so I am putting N there, NBA cos theta. That is equal to minus d by dt of NBA cos omega t. Why? Because omega is equal to theta by t. You learned it in first year classes. Angular velocity is equal to what? Velocity is equal to what? Displacement by time. Velocity, linear velocity is displacement by, it doesn't matter, magnitude alone is asked. So linear velocity is what? Linear velocity is linear displacement by time, angular velocity is angular displacement by time. Cross multiply, theta will be omega t. That is what exactly I've written here, no? That is exactly what I've written here in BA cos omega t. So I can differentiate this. You know how to differentiate? N is taken outside, B is taken outside, A is taken outside. D by dt of cos. D by dt of cos is what? Minus sine omega t into omega. You know why I put an extra omega? We have done this in class as a derivation, right? Cos omega t's differentiation is what? Cos t's differentiation is minus sine t. But when there is an omega here, you'll have to differentiate it one more time. That means you have to multiply with omega. So this is what? Minus or minus plus n b a omega sine omega t. This is the equation for EMF. And EMF is given by E0 sine omega t. This is where we start the chapter alternating currents. Okay. Right. With this equation, E is equal to E0 sine omega t. Repeating one more time. We have two coils, copper and aluminum. They are being rotated in the same magnetic field, and with same angular velocity. EMF is minus d phi by dt. That is minus d by dt of n ba cos theta. Why? Phi is b dot a, which is ba cos theta. But since there are n turns, I would put n here, n ba cos theta. And theta is what? Like I said, theta is, if you cross multiply, it is omega t. So n ba cos omega t. Right. I differentiate. N is taken outside, B is taken outside, A is also taken outside. Minus n ba into. What is d by dt of cos omega t? It is minus sine omega t into omega. This is called chain rule or function of a function rule. Minus of minus is plus. If you didn't understand this part, please tell me, I can repeat. Sine omega t's, cos omega t's differentiation is, cos's differentiation is minus sine omega t. Into this part should be differentiated one more time. Omega written as such, t's differentiation is 1. So if I take them together, minus or minus is plus, NBA omega sine omega t. Now let's say NBA omega together is called E0, is equal to E0 sine omega t. And in the question, they ask you to compare the EMFs in both cases. In the case of copper and aluminum, what is EMF? EMF is NAB omega sine omega t. Look at this. Both the coils identical, two identical loops. So if this has one loop, this also has one loop. So number of turns is same for both. Area identical, same, area is gone. Rotated in same magnetic field, B is gone. Rotated with the same angular velocity, omega is also gone, which means E copper will be same as E aluminum, right? So that is the first part, right? E copper and E aluminum will be same, but currents will be different. Why? E I copper is equal to E copper divided by R copper. E copper I can write it as C. I aluminum is equal to what? E divided by R aluminum. But you know, R aluminum is greater than R copper. Copper has less resistance, no? Lesser the resistance, greater is current. So I copper is greater than I aluminum. That will be the answer to the second part of the question. First part is this. Okay, I'll repeat that part one more time. See this? So we got the final equation here, NAB omega sine omega t, and they are asking you to compare the EMFs of copper and aluminum. So for copper and aluminum, they are identical loops. So N is the same for both, number of turns. If one turn, two turns, 5 turns, 5 turns. N is the same for both. Area, identical. Area is the same for both. B, rotating in the same magnetic field. Magnetic field is same for both. Omega, same angular velocity, same for both. Then EMF is same for both. Sine function is also same. Omega is same, no? So EMF is same for both. EMF of copper is same as EMF in aluminum. EMF in copper is same as EMF in aluminum. But for current, you have to use Ohm's law, right? Ohm's law is current is EMF divided by resistance. EMF is E copper and E aluminum are same. So I can use capital letter E for it. So E divided by R copper, and this is E divided by R aluminum. Who has greatest resistance? Least resistance? Gold. Then comes silver. Then comes copper. Then comes aluminum. Okay. See the sequence? Gold, silver, copper, and then aluminum. Copper has lesser resistance. Lesser the resistance, more is the current, because they are inversely proportional. One is on numerator, the other one is on denominator. So R copper is less than R aluminium, I copper is greater than I aluminium. Lesser the resistance, greater is the current, and vice versa. So who has greater current? Copper has greater current. Did you understand? Moving on to question number 19. A coil of number of turns N, area A, is rotated at a constant angular speed omega in a uniform magnetic field B and connected to a resistance R. A coil of number of turns N, it's called N turns. And then what? It is area, its area is A, is rotated at a constant angular speed. It is being rotated with the constant angular speed omega. See this? It is being rotated with the constant angular speed omega in a uniform magnetic field B and connected to a resistor R. It's being connected to a resistor R, okay? And then what? Reduce expression for maximum EMF, power dissipation. How do you find? EMF is given by what? Minus d phi by dt. You got only Lenz's law. Minus d phi by dt. We have just done this. Minus d phi by dt. Minus d by dt of what is phi? N B A cos omega t. N is a constant outside. B is a constant outside. A is a constant outside. What is d by dt of cos omega t? Minus sin omega t into omega. Minus or minus is plus. Plus N B A omega sin omega t. This is EMF. They are asking about maximum EMF, which is given by this. This is called E0, maximum EMF. So what is the equation for maximum EMF then? That is the first question. NAB omega. N is the number of turns, A is the area, B is the magnetic field, omega is angular velocity. This is maximum EMF. Power dissipation is also asked. Power dissipation is easy to find out. E square divided by R. We have done this many times now. So here NAB omega the whole square divided by R. That makes it N square A square B square omega square by R. That will be the power dissipated. This is maximum power dissipated. But if they say power dissipation, sin omega t is also to be used. So NAB omega sin omega t the whole square. So it is sin square omega t. That will be the power dissipated. Repeating one time. EMF, they are asking for maximum EMF. So I should find EMF first. EMF is minus d phi by dt. That is minus d by dt of N B A cos theta. Because flux is B dot A. That is B A cos theta. N B A cos theta. N B A cos omega t. N is taken outside, B is taken outside, A is also taken outside. D by dt of cos omega t is what? Minus sin omega t into omega. Minus or minus is plus. N B A omega into sin omega t. NAB omega together is known as E0. E0 sin omega t. So E0 would be what? NAB omega. N is number of turns, A is area, B is magnetic field, omega is angular velocity. And the question is to find out this maximum EMF. We have answered the first part. Second part is on power. Power is E square by R. So E is what? NAB omega sin omega t. NAB omega sin omega t the whole square divided by R. Now, like I did, if you forget, like I forgot, if you forget to put sin omega t, you won't lose marks. Don't worry. So NAB omega sin omega t the whole square by R. N square, A square, B square, omega square, sin square omega t divided by R. Did you understand this?